Okay, hello and welcome to January 2021 Foundation Paper 1FR. So it's a regional paper. So we're going to go through this paper together. I suggest you pause the question before I go through it, and then you can see how I've done it. Okay? Okay, this is the formula sheet given to you. You may need this during the past paper. Can you also make sure you have all your equipment ready? Right, let's get started. Question 1. So, the table shows the heights in meters of 5 mountains. Which of these mountains has the greatest height? So we can see we have 4,000, 4,000, 5,000, 8,000, 6,000. What's the biggest number? 8,000, so it is Kaloo. Now, you can see it asks which mountain. It didn't say how high, so we have to write the word of the mountain, not the actual height. It then says, write this number in words. If I was to say this number, how would I say this number? 5,000. So 5,000. 800 and 90 95. Okay, so 5,895. The next part says write down the value of 8 in 4, 8, 10. If you think about 4, 8, 10, 4 is thousands, 8 is hundreds, 10 is tens, 0 is units. So the number 8 is in fact hundreds. So write down the value of 8 is 800. Now you can actually write 800 if you want. You don't have to spell it. Okay?
If you spell it and write it.
If you spell it or write it, you're still going to get 1 mark. Part D, it says work out the difference between the height of Aconcagua and the height of Puncajaya. So first thing, let's go back to the table. What is the height of Aconcagua? 6961. What is the height of Puncajaya? 4884. And I've done that by looking at here. Akonda 6961. Puncajaya 4884. So the difference, what is it asking me to do? Subtract them. So I'm going to take away 6961 minus 4884. I know this is a calculator exam. However, I want you to know that, you should be able to do this without a calculator as well. Okay? So once I put it into my calculator, I'm going to get 2077, and then remember we should be able to subtract anyway. Okay, so here I'm not going to teach this. We should be able to do this, and you can check that what you've done is correct. Now, just to clarify, if it's a 1 mark question, you do not need to show working out. If it's 2 marks, you need to show it. If it's 3 marks, you need to show it. If it's 1 mark, you do not need to show it. However, it is good practice to show what you're writing in either your calculator or you're working out. So if you were to write 6916, and then instead of that, you wrote minus here, this is showing you're working out. It's showing what you're putting into your calculator. Okay, so that's the first question done. 4 marks. Question 2. Caroline has a bag of 10 counters. So in the bag there are 7 red counters, 2 blue counters, 1 green counter. Caroline is going to choose a random counter from the bag. Write down the word from the box that best describes the likelihood that she'll take a red one. Well, if we wanted to, we could even do this. We could have 1, 2, 3, 4, 5, 6, 7 red, 2 blue, and 1 green. Well, I would say it's more than even, because if this was even, there's a total of 10, there should be 5 red. It's not certain, because not all of them are red. So it's going to have to be likely. It is the most probable, and this is what we're doing, probability. And sometimes when we look at these questions, we go through and do it. Then, what is the probability of getting a yellow one? Well, are there any yellow counters? No. So it is impossible. Impossible. Next, it says Jamal is going to roll a first 6-sided dice. Okay, a first 6-sided dice, believe it or not, how many sides does a dice have? Tells us in the question 6. And we know on a dice, we have 1, 2, 3, 4, 5, 6. When I roll a dice, this is all I can roll. So, we have to think. It says the probability will lie on an odd number. How many odd numbers are there from 1 to 6? 1, 2, 3 out of what? What is 3 out of 6? It's a half. So, exactly here, we have 50% chance, don't we? On the probability scale, mark with a cross the probability that dice will land on a 2. How many 2s do we have? 1 out of 6. So if I look at this, I need to split this into 6. If we look, it's already been split into 6. 1, 2, 3, 4, 5, 6. So 1/6 is here. This is 1 out of 6. Question 3. Here is a quadrilateral. The quadrilateral has how many sides? 4. That's why it's called quad. Okay. What is the mathematical name of this quadrilateral? A quadrilateral with exactly 1 pair of parallel sides is called a trapezium. So let's write that down. Trapezium. Trapezium. You should be able to spell this completely correctly because it's also in the formula sheet. In the formula sheet, it tells us the formula for area of a trapezium. The next, it says measure the angle marked X. Now, everyone needs their protractor, please. So we're going to get our protractor out. Everyone should have a protractor. Please use your protractor. So when you measure, you put your protractor, you want to put the dot on the angle, and then you want to put the straight line. So if we, wrong thing, I'm zooming in. So dot where the angle is, and then the straight line on top. Check. Now, have a look. If I'm measuring this angle, I want to measure how wide this is. So when I go across here, am I going to use 180 or 0? 0, because when we start to measure, we start from 0. So I go across 0 all the way till I get to the line of the shape. What do I get up to? 40. Then I do 41, 42. So this is 42 degrees. Okay? And I'm just going to show you. If I move that out the way and I put, you can see where we're going to measure this. So you can see underneath. If I move this, this is highly frustrating. If I move this back, that's the angle we're measuring, is this angle here. Okay, so you can see this angle we're measuring, this is 60 degrees. Okay, next up, it then says, on the quadrilateral, mark with arrows, and it says 2 arrows, a pair of parallel lines. Well, I already did that earlier. However, it wants 2 arrows. Now you're going to get a mark. The next one says the quadrilateral has 4 angles. How many of these are right angles? Well, a right angle, we know, looks like this, 90 degrees. 1, 2. So there are 2 right angles. Now, can you also see I am writing all of my answers on the dotted line? Question 4. Iwan is going to buy the following items. Now, first of all, let's just check how many marks this is. 4 marks. Do we need to show all of our work in? Absolutely. So, he's going to buy the following items. So we've got 1 plant pot is £8. Okay, so I've got a plant pot. How much is it? 8. 3 bags of soil, £4.50. If I wanted to, I could draw 3 bags of soil. So what's that? £4.50 plus £4.50 plus £4.50. What does that equal? £13.50. And again, you can use this into your calculator, however I've written it down. Then it says some bags of seeds. So we're going to have some bags of seeds. Do we know how many seeds? No, but I know a packet of seeds is £1.10. Okay. He has a total of £30. How many packets of seeds? He buys as many as he can. So first of all, I can do this 2 ways. Let's figure out how much he's spent in total so far. So with his plant pot and his soil, 8 plus 13.5. So this is £21.50. Okay, he has a total of £30 altogether. So how much does he have left? Well, that means 30 minus 21.50 is going to be £8.50. So he's got £8.50 after he's bought his plant pots and his soil, okay? He's got £8.50 left from the £30. How many bags of seeds can he get? Well, we can do this a few ways. We can literally, if we wanted to, count up. £1.10. What if he got 2 bags of seeds? How much is that? That's £2.20, isn't it? What if he got 3 bags of seeds? £3.30. So what if he got 4 bags of seeds? £4.40. Realistically, I could keep going up 5, 6, 7. But what should I choose? An intelligent guess right now. Oh, let's try 8 bags of seeds. 1, 2, 3, 4, 5, 6, 7, 8. What does that give me? £8.80. Do I have £8.80? No, I've got £8.50. So what would be the next logical guess? 7. So if I did 7 bags of seeds, how much is that? £7.70. Okay. Right. Do I have enough money for that? Okay, so I can buy 7 bags is £7.70. Right. I've got £8.50. How am I going to find the change? £8.50 minus £7.70 is going to give me 80p, which is £0.80. Okay, because if I take these away from each other, it gives me 0.80. So can you see how this question, for 4 marks, I've shown all of my working out? Yes? Now, I haven't actually used a calculator. I've used mental mathematics. Yeah, I did this all in my head. Some of you used a calculator, that's fine, but this is the minimum requirement, is to write this working out. Do you see how I drew pictures to help me? And then when I wasn't sure here, can you see how I started saying, right, well, what would happen if I had 2 bags, 3 bags, 4 bags? And what I started doing is I noticed a pattern, didn't I? And then I made a reasonable guess, thinking, well, let's try 8 bags. Okay, and it would be too much. So we're using reasoning and logic. In these types of questions, we have to think about, does this really make sense? Okay, and let's think about it now. We don't have to do this, but let's just have a quick double check. Right, let's double check. If he bought 1 plant pot is how much? £8. If he then bought 3 bags of seeds, how much was that? £13.50. How many bags of seeds did we buy? 7. And what did we say that cost? £7.70. Let's just check. How much do they all add up to? Okay. This should, in theory, if we had 80p change, what's 30 take away 80p? It should give me £29.30. Sorry, not £29.30, £29.20. Did we get £29.20 when we added them? Yes. Because £30 minus the change should give us £29.20. That should give us what we've said he could get. Is that true? Yes. So we also know we're right. We can prove that we're right. Once you've worked it out, you can walk out and say, do you know, I definitely got those 4 marks. It does make sense. So when you're in the exam and you've got time left over, and I always say, go back and double check your work. I want you to double check your logic. Okay? Well done. Question 5. Here we have a diagram. It shows the point A and the line CD. Write down the coordinates of A. It's -2, 3, because we always read off the horizontal x-axis first and then the y-axis, which is the vertical. -2, 3. Oh, wrong pen. -2, 3. You always read the horizontal, the x first, then you read the y. Even if the point was here, we always do the x first. So this point would be, what would this point be? 2, -1. Absolutely correct. Okay, next part of the question. Okay, one of my students has just said, we have to do it in alphabetical order, and X comes before Y in the alphabet, so we do the X-axis first, then the Y-axis. That could be a good way to remember it, couldn't it? Okay, the next one says, the point B has coordinates 4, -2. On the grid, mark with a cross the coordinates. Now, coordinates are always X first and then Y. So where is 4 -2? So I'm going to do X first, which is this horizontal line. 4, and then -2. Up or down? Down, which is here. So here is my coordinate. You have to put a cross because it says put a cross in the question. It then says write down the equation of the line CD. Have a look at this horizontal line CD. What is the equation of this line? What do we notice about this line? It is a straight line. And look at all the points. Can someone tell me what is this point? -4, -3. Can someone tell me what's this point? -1, -3. Can someone tell me this point? 2, -3. What do we notice so far about all the points on this line? Our y coordinate is always -3. This is the line y equals -3. For any point on this line, my y always equals -3. Question 6. Okay, so here is a shape made of squares. Shade 3/5 of the shape. What does that mean? We shade 3 out of every 5. How many squares of 5s do I have? 2. I've got, this is 5, and this is 5. So I've got 2 lots of 5s. So if I'm shading 3 out of every 5, 1, 2, 3 out of 5. Then again, 1, 2, 3 out of 5. Okay, so that's how we shade it. Another way, how many do we have in total? 10. So 3/5 is equivalent to what over 10? 6/10, isn't it? How would we show that? We'd have to multiply our numerator by 2 over 2 because our denominator was multiplied by 2. And remember, 2 over 2 is a whole one, so we're not changing the quantity. This is what makes it equivalent, so we have 6 out of 10. Next one says, write 36 over 120 as a fraction in its simplest form. 36 out of 120. Do 36 or 120 have a common factor? They're both multiples of 10? Not quite. 36 is not a multiple of 10. They're both in the 6 times table and the 2 times table and the 12 times table. However, 12 is our highest common factor, but it's okay if you don't know that yet. Okay? Because if we wanted to, so we said 6 to begin with, didn't we? So if we divide both sides by 6, our numerator and our denominator by 6, 36 divided by 6 is 6. 120 divided by 6 is 20. And then you say to yourself, because we want it in its simplest form, do 6 and 20 have a common factor? They can be divided by 2. 6 divided by 2, 20 divided by 2, 10. So this becomes 3/10. Another way to look at this, which is becoming increasingly popular, and I do prefer this way, 36 over 120 can be written as 12 times 3 over 12 times 10. They both have 12 times. We can divide a common factor of 12 on the numerator and denominator to get 3 over 10. Perfect. Part C. Write these fractions in order of size. Start with the smallest. Now, we can convert these all to the same denominator. However, think about it logically. If we have, let's start with one that's the easiest. Imagine this is a number line. We have a half. Okay. Is 3/4 bigger than a half? Yes or no? Yes. Why? What would, because it's 0.75, we know that. So we know 3/4 should be here. So far, we definitely know 3/4 is bigger than a half. Because if we split this into quarters now, yeah? Next is 5/6. Okay? What is 5/6? 0.83. Okay, is that bigger than 0.75? Yes, so 5/6 is going to be bigger. Brilliant. And we know a half is 0.5. How about 4/5 is 0.8? Where would that go? In the middle, 0.8 is going to go in the middle of 0.75 and 0.83. So what's the smallest? A half, then 3/4, then 4/5, then 5/6. Okay? Another way we could do this is convert them all to the same denominator, but it's easier with simpler fractions to convert them to decimals if you need to. Right, it then says 5/9 of a number is 14. So what if we split the number into 9 parts? So if I had a number and I split this into 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And can you see how I didn't quite draw my bar model correctly, but I just added it on? That's fine. So how much is 5/9? How many do I shade in? 5 out of 2, 3, 4, 5. 5/9. This is what? 14. It says 5/9 of a number is 14. So if I know 5 bars is 14, how do I work out 1 bar? Exactly. So 14 divided by 5 is going to give me 1 bar, which is 2.8. So each one of these is worth 2.8. So does 2.8 times 5 give me 14? Yes, so I know I'm right. I'm doing that logic again. Right, so if I want to work out the whole number, how many parts are in the whole number? 9. So what is 2.8 9 times? That's going to give me the whole number. So 2.8 multiplied by 9. 25.2 is the final answer. And we've split that up. We've used the bar model, we've used some reasoning and logic. This is the best way to approach these types of questions. Question 7. So, Kate asked the 60 members of a leisure centre. So this means our total frequency adds to 60. How many times they had each visited the leisure centre last week? The table gives the information about her results. So this means 4 people visited 0 times. 12 people visited 1 time. 17 people visited 2 times. 20 people visited 3 times. 7 people visited 4 times. Write down the mode of the number of visits. So the most common number of visits was how many times?
3.
It was 3 because that had the most amount. So 20 people said they visited 3 times. So write down the mode of the number of visits is 3. And it gives you a clue in the question. If it wants the mode of the number of visits is 0 to 4. So it has to be one of these numbers. Okay, we need to read the question and read the graph. It then says, Kate is going to draw a pie chart for the information on the table. So we're going to draw a pie chart. What does a pie chart look like? A circle. How many degrees are there in a circle? 360. So I know that around a point is 360 degrees, okay? Work out the size of the angle in the pie chart for the sector representing 1 visit. Okay, so how many people, what was the frequency of 1 visit? 12 out of 60. If I need to draw a pie chart which is out of 360, what do I multiply 60 by to get my equivalent fraction? 6. So I need to multiply by 6 over 6. 60 times 6 is 360. 12 times 6, 72. So to make this proportionally accurate, it means my sector would have to be 72 degrees because it's out of 360. So 12 out of 60 is proportionate to 72 out of 360. The other way you could do this is, if you were to think about a pie chart, and if we split this up into 60s, how many 60s are there? 6. So here are my 6 lots of 60 degrees, right? But if I'm only shading in, okay, 12 out of 60. So for every 60 I shade in 12. How many 12 do I need to shade in? 6. 6 of the 12. 6 times 12 is 72. So the total is 72 degrees. Okay? Then says 35% of the 60 members are aged 50 or over. How many members are 50 or over? So if 100% is 60, I need to work out how much? 35%. Okay? Now we can do this in a few ways. So first of all, by looking at this, if we're working out 35%, right?
Find out 10%.
we know, how could we make 35%?
Find out 10%, multiplying that by
10% and 5%. That would help us, wouldn't it? How do I find out 10% of 60? We're going to divide it by 10, which gives us 6. So if this is a 10%, 10%, 10%, and a 5%, I know 3 10% are 6, 6, 6, and 5% is 3. 6 plus 6 plus 6, 18 plus 3, 21. Now think about this, 35%, is that less than 50%? What's 50% of 60? 30. Is 21 less than 30? So doing my common sense check, does this make sense? Would 35% be roughly 21? Yeah, of course it would. Now there's another way we can do this. If we're going to find 35%, that's the same as finding 35%. If we were to use the multiply method, we do 60 multiplied by 35%. What is 35% as a multiplier? That means 35% is a decimal. 35% is a decimal. How do we get this into decimal form? Divide by 100, 0.35. Now I know a lot of us already know that. If we type this into our calculator, what do we get? 21. So we also know we are correct. Question 8. Simplify A times A times A times A. What is this the same as?
A to the power of 4.
A to the power of 4. Perfect. Simplify 4b times 5c. 20 BC, because we're going to multiply the numbers first. 4 times 5 is 20. B times C is BC. Simplify 6d plus 2e plus d minus 5e. So 6d plus d is 7d's. Then we have 2e minus 5e is negative 3e. Okay? So remember, when d on its own is one lot of d. Yeah? It's 1 times d. It's 1d. However, we don't write 1d, do we? No, we just write d. You wouldn't say, I have 1 pencil. You just say, I have a pencil. That would imply 1, wouldn't it? Not multiple, absolutely. Sometimes we don't have to write 1 of something to just imply that you have singular. A, absolutely. Okay, number 9. Right, now I'm looking at this and immediately I see lots of sentences. Okay? So we need to read it, break it down and create some mathematical sentences. Are we ready? Sabri has some boxes of banana and some snacks of tomatoes. Sorry, sacks. The weight of each box of bananas is the same and the weight of each sack of tomatoes is the same. The weight of 3 boxes of bananas is 42 kilograms. The weight of 8 sacks of tomatoes is 68 kilograms. Work out the total weight of 9 boxes of bananas and 15 sacks of tomatoes. Okay, there's a few ways we could approach this question. Number 1, boxes of bananas. I'm going to draw a rectangle. Sacks of tomatoes. I'm going to draw a squiggly bag to show it's a sack. Okay? So 3 boxes of bananas is 42 kilograms. How many boxes of bananas do I need to work out? 9. How could I do this?
9 times 40. No, 3.
I could actually, if I want 9, if I know what 3 is, I could just multiply 42 by 3. Okay, so this is 42, 42, 42. This is 42 times 3, 160. No, 126. Okay, what was another way I could do it?
42 divided by 3.
I could do 42 divided by 3 to figure out what 1 box of bananas is, which is 14. And then I could times 14 by 9. Either way, well, let's have a look. What is 14 times 9? Should we get 126? Absolutely. So let's check we're right. What's 14 times 9? 126, perfect. So either way is correct. And this is what's so beautiful about mathematics, is that we can manipulate it. Isn't that beautiful? More than one way. Okay, I'm going to change a different pen for my sacks of tomatoes, just so we don't get confused. How many sacks of tomatoes do I need to draw? 8. 1, 2, 3, 4, 5, 6, 7, 8. And how much does that equal? This equals 68. How many do I need to find? 15. So what could I do in this case? How could I find, like earlier we tripled this to get 9, but does 8 go into 15? No. Okay, so what would probably be the better alternative is to find 1. How would we find 1? We'd do 68 divided by 8, because there was 8 sacks, right? So 68 divided by 8 is 8.5. So 1 tomato sack is 8.5. How many do we need to find? 15. So if I know 1 is 8.5, how am I going to find 15? I'm not going to draw 15, but imagine I did. 15 times 8.5. So it's 127.5. So now we know what 15 sacks are. 15 sacks of tomatoes is 127.5. 9 boxes of bananas is 126. So the question says, what's the total weight of all of this? What am I going to do? I need to add them together. 126 plus 127.5 is going to give me 253.5. Now, I've written it there. However, where am I going to write the final answer? Here. So, the other thing is, could I have done this without drawing pictures?
Yes.
I could have used algebra, actually, couldn't I? So let's quickly take a look at how I would use algebra. So instead of drawing 3 boxes, okay, I could have written 3 times by, and what could represent our boxes? B. This equals 42. So this is saying 3B equals 42. Okay? And then from there, how would I find 1B? Divide them by 3, etc. We could do the same manipulation. This is exactly the same as this, just written in algebra. And this is using pictures. Both of these are equally as important. If you can draw pictures, you can write algebra. If you can write algebra, you can draw pictures. And then the same for the sacks of tomatoes. We've got 8 times sacks of tomatoes is 68. So we can simplify that to 8s equals 68. And again, the same thing. So using algebra is also just as easy. Now, in your exam, if you don't write this method and you've just written the answer, you will not get the marks. Question 10. The diagram shows the isosceles triangle ABC, in which AB equals AC. What do we know about isosceles triangles?
They have 2 parallel lines.
They don't have 2 parallel lines. A triangle does not have parallel lines. They have 2 lines at the same size, and also the 2 angles here are equal. Okay? And it says that BCD is a straight line, so this is a straight line. Perfect. It says work out the value of x. Okay, so what do I know? I know that angles in a triangle add up to 180. So a triangle equals 180 degrees. So, how would I find the other 2 degrees? I would need to do 180 minus 44. 180 minus 44 is 136. Now, we actually know that these 2 angles are equal. So what would we do?
136 divided by 2.
we would divide it by 2, which is going to give me 68 degrees. So I know that this is 68 degrees. This is 68 degrees. Now, how could I double check right now before moving on that what I've done is correct? I could do 44 plus 68 plus 68 and check that this equals 180. Shall we double check quickly? And it does equal 180. So I know so far I am correct. So I'm just going to draw this as well for you. So we know that 180 equals 44 plus 2 angles which are the same. Okay, so this means 136 equals 2 angles that are the same. So if I want to find one of them, this is drawing a picture, I'm going to divide by 2. Now the next part, it told us that this is a straight line. What do we know about angles on a straight line? They add up to 180. So x plus 68 adds up to 180. So how am I going to find the missing angle? 180 minus 68, which equals 112 degrees. So x equals 112. And what I've done is I've showed every step of my working. Okay, so I've got all the steps of my working, and this is what you need. Question 11. On the grid, draw the graph of y equals 3 minus 2x for the values of x from minus 3 to 2. Okay, we're going to rewrite this. I'm going to show you a really handy trick to help you here. We're going to substitute in values x from minus 2 to 3. So we're going to rewrite this equation. Y equals 3 minus 2 bracket. Wherever we have our x, we're going to have a bracket. It's really important we do this because we're going to use substitution. And whenever we substitute, we need brackets. So now I need to substitute in my values from minus 2 to 3. Now it is quite nice when we first learn about this, and we're doing this, to draw a table. So we're going to draw a table. Our x values, what have they said it's from? Minus 2 to 3. So minus 2, what comes after minus 2? Minus 1, then 0, then 1, 2, 3. And then to find y, we're going to use this formula. But every time, so x in this case is minus 2. So 3 minus 2 lots of this one. I'm just going to write this down. However, what I'm about to write in blue, I wouldn't write. The first one here is 3 minus 2 lots of our x, which is minus 2. This one is going to be 3 minus 2 lots of our x, which is minus 1. This one's 3 minus 2 lots of 0. Why? Because our x is. So can you see for each one I've written this formula? I would not write this down. I would just make sure this is what I was doing. Okay? Now, what's really important is that we work this out correctly. So, you can, if you want to, put this straight into your calculator. However, we should be able to do this. 3 minus, you can leave that minus second. What's 2 times minus 2? So 3 minus minus 4 is 7. 3 minus minus 2 is 5. 3 minus 0 is 3. 3 minus 2, 1. 3 minus 4, minus 1. 3 minus 9 is minus 6. Wait, that doesn't make any sense. 1 second. 3 minus 4 is minus 1. Minus 2 is minus 3. Oh, I know what I've done wrong. That wasn't a 3. This is a 2. Sorry, I got carried away with all these 3s. Yes, but I've written it wrong. And this is really good to see, actually, because we thought it was 12 because I'd written the equation wrong. We should, because this is a straight line graph, it should go the same distance. How do I get from 7 to 5? Minus 2. How do I get from 5 to 3? Minus 2. 3 to 1? Minus 2. 1 to minus 1? Minus 2. Minus 1 to minus 3? Minus 2. This is how I know I'm right. The difference will always be minus 2 because that is our gradient. I can now plot the graph. So, here we go. We're going to have our first coordinate is minus 2, 7. Minus 2, 7. The next one is minus 1, 5. Okay, so you plot the graph and we'll see it in a second. Remember to use a pencil and a ruler when you connect the dots. So, when you connect the dots, you're going to use a ruler. Now, your ruler, please make sure you just don't do dot to dot. You need to connect from the edge of the graph to the edge of the graph. Now, there is another way to do this question. And those of you who are aspiring to do higher mathematics, really we should learn this way. So I'm just going to quickly show you. Y equals 3 minus 2x. Now we know that y equals mx is an equation of a straight line. Our plus c is our y-intercept. This is where it crosses the y-axis. And our m is our gradient. This is our change in, for every one along, how much do we go up, okay? It's our change in y, essentially. So, that's how steep the slope is. If I rewrite this equation in this form, I get y equals 2 minus 2x plus 3. So, plus 3. This is where I cross the y-axis. Do I cross at 3? Yes, it crosses at 3.
Oh, yes.
And it does, so I know I'm right. Then, this minus 2x is our gradient. This says for every one along, okay, for every one along I go down 2. Is this true? Yes, because in this case, this 2 boxes is represented by 1 along the x-axis. So every one along, I go down 2 because it's negative 2 minus 2. Every one along, I go down minus 2. Okay, so this is another way you could have drawn it. And you can also check. So it's really good to start learning this because we will need to know this. Question 12. Rose and Hayden share £250 in the ratio 2 to 3. Okay, before we read the rest of our question, shall we start with how much Rose and Hayden have?
Yeah.
So, if Rose has 2 parts and Hayden has 3 parts. So this is Rose and this is Hayden. And you can see I'm using a picture. What does the total add up to? 250. So how many boxes equal 250? 5. So how am I going to find one box? So 5 parts equals 250. So 1 part is going to be 250 divided by 5. So what does 1 part equal? 50. So I can write this in. 50, 50, 50, 50, 50. And I can double check. What's 50 plus 50? 100. 100 plus 50. 150. 150 plus 50. 200. 250 plus, 200 plus 50. 250. Was that the total?
Yes.
Yes, I'm constantly checking that what I've done is right. Okay, this is fantastic. So yes, I know this is right. So how much does Rose actually have? 100. And how much does Hayden have?
150.
150. Let's double check again. Is 100 plus 150 250? I know I'm right. Okay, perfect. Next, anyway, let's read the rest of the question, shall we? Rose gives all her share of the money to charity. So how much does Rose give to charity?
100.
She gives 100 to charity. Hayden gives 42% to charity. So what do we need to do?
Find 42%.
We need to find 42% of 150, don't we? Because that's how much Hayden has. So if we had a bar model and we have 100%, and 0. We know this is roughly 50, don't we? So 42% is less than 50%. Okay? Now, how am I going to find that? So, this one wasn't as easy as the last one where we found the 10%, the 5%, you know? We could still do that. We could find the 10% and we could find 1% if we wanted. Okay? However, we could also use the multiplier method. If we're finding 42%, what is 42%? 150 times 42% is a multiplier. 42% is a multiplier is decimal form. We need to divide by 100, 0.42, which is going to give me 63. Now, let's just double check this makes sense. What's half of 150? 75. Is 63 less than 75? Yes, this makes sense because 42% is less than 50, isn't it?
Yeah.
Now, for those of you who didn't use the multiplier method and you did, if you worked out 42% by finding 10%, 1%, if you found 10% and times it by 4 to get 40, 1% by 2 to get 2%, 10% is, of 150 is 15. So 15 times 4 is 60. 1% is 1.5. Times 2 to get the 2% is 3. 60 plus 3 is 63. So again, another method. That's completely acceptable. So how much did he give to charity?
63.
63. So Hayden gave to charity 63. Then says Rose gives more money to charity than Hayden. So this is a clue. Rose got 100, Hayden got 63. Is 100 more than 63?
Yes.
Yeah, so for example, if you got here 104, would you know that you've gone wrong? Yes. Okay, they're giving you clues in the question. It then says work out how much more. So how much more did Rose give? How am I going to figure that out? 100 minus 63, which is 37. So £37 more. Now remember, I'm going to write this down. Even though I've done all my work and I'm going to write it on the line. So there we go, we've worked out. This is a 5-mark question. And we've broke it down. Well done. Question 13. A circle has diameter 18 centimetres. Work out the area of the circle. Now this is not in our formula sheet, but we should all know this. Area of a circle is pi r squared. This is what area equals. So, for this, we know the area, we need pi times the radius squared. So, what information do we need? Radius.
Yeah.
The question says a circle has a diameter of 18. Has that given me a radius?
No.
What do I know about the diameter and the radius? The diameter is twice the length of the radius. So if the diameter is 18, we need to divide it by 2 to find the radius, which is 9. Do we now have the information we need? Yes. To find the area then, I'm going to do pi times, and whenever I substitute, I use brackets, 9 squared. This is going to give me 81 pi. Exact. However, it wants it to 3 significant figures, so I can press the SD button on my calculator, and this gives me 254.469, blah, blah, blah. 3 significant figures. The first one is hundreds, the second is tens, the third one is ones. So it means we're rounding to the nearest one. What is this number rounded to the nearest one? It's just 254, because the number next to the decimal 4, is this 5 or more? No, so we don't round up. So there we have it. Nice and simple for question 13. So then, question 14. Question 14 is worth 5 marks. Okay? So I suggest whenever we have a diagram, we use a pencil. Please get your pencil out. So here we go, using our pencil. It says the universal set. So this means the universal set. So the only numbers allowed to be in this box or in the circles are these numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We cannot use any more of these numbers. Okay. So this, in this circle, can only contain A, which is 2, 4, 6, 8, 10, 12. So in A, we have 2, 4, 6, 8, 10, 12. In B, we have 3, 6, 9, 12. Now tell me, what do I notice? This part here is where A and B overlap. Do A and B have anything in common?
Yes.
They have?
6 and 12.
So I'm going to write 6 and then I'm going to rub it out from both sides. That's why I've used a pencil. Perfect. Do they have any other numbers in common?
No.
12.
Oh, no, 6 and 12.
So I'm going to rub out 12 now that they're both in common. Okay, so this makes sense. Brilliant. Done. Now, what goes on the outside? Have I written the number 1 anywhere? No. Okay, so that goes on the outside. 2. Yep, it's in A. 3. Yes. 4. Yes. 5. No. Okay. So that needs to go there. 6. Yes. 7. No. 8. Yes. 9. Yes. 10. Yes. 11. No. And the last number, 12. Yes. And do we have all the numbers 1 to 12 in our box and in our circles? This is our Venn diagram. We've put everything in. We've done A, we've done B, and the ones that match, 6 and 12, I mean, you could even, if you wanted to, go through and do 6 and 12 match first, and you could have started by doing that. Perfect.
I don't have a pencil.
So, part B. It then says, one of the numbers in, and this squiggly E is the universal set. So one of the numbers of this thing is to be chosen at random. How many numbers do we have?
4.
12. In the universal set, the whole thing, there's 12. So one's going to be chosen at random. So one of them out of how many? 12. Find the probability that this number is not in set A and not in set B. So first of all, if we're choosing it at random, we're thinking about probability. How many options do we have available? 12 options. 12 options.
12.
But how many are not in A or B? Where is A and B? Here and here. How many numbers are not in A or B? 4 different numbers. So we have 4 out of 12 chances. So you can write 4 out of 12. If you did simplify that to a third, that would also be acceptable. However, the 4 out of 12 really shows that there was out of 12 options and 4 of the numbers were not in A or B. Okay? Question 15. Expand 5 lots of 3A plus 4. What does this mean? This means 5 times 3A plus 4. Okay? This means 5 times that. If we were to do 5 times 4, what does that actually mean? That means 4 5 times, doesn't it? 1, 2, 3, 4, 5. It gives us 20. This means this bracket 5 times. However, we're not going to write this bracket 5 times and then work it all out. We could if we wanted to, but there is a quicker way. Okay, this is what it means. 5 times this bracket is 5 lots of this bracket. However, we could do 5 times the first term. 5 times 3A is 15A. 5 times 4 is 20. And let's check that this is right. If I think about this, I have 3A, 6A, 9A, 12A, 15A. Is that correct? 4, 8, 12, 16, 20. So 15A plus 20. However, we use different methods, don't we? So this becomes 15A plus 20. The next one says factorise. Factorise has the word factor. We're looking for a common factor between 4C and 14. Does anyone know what's common between 4C and 14? They're multiples of 2. They're both in the 2 times table. And we only have 1 letter, so that's okay. So if I imagine, right, I've got 4C minus 14. If I took 2 out, 2 times what is 4C? 2C. 2 times what is negative 14? Negative 7. So we would now write that. We take out 2 as a factor, lots of 2C minus 7. could we check that we are correct? Could we check we are correct? Yes, we could do 2 times C, 4C, 2 times -7, -14. This is correct. Okay, the last one. C, solve 5x minus 11 equals x plus 6. So, whenever we solve equations, we want to find what x is. What we're saying here is 5 times a number minus 11 is the same as that number plus 6. That's what we're saying. Okay? Now we have to use a balancing scale here. I want the box on its own. So, we could add 11 to both sides to get rid of this 11. Whatever I do to one side, I have to do to the other. So I'm left with 5 lots of a number equals that number plus 17. So now if I take away that number from both sides, okay, I'm left with 5 lots of a number minus that number is 4 lots of that number equals 17. So how do I now find that number? Yes, because I have to divide both sides by 4 to find out what 1 is. 17 divided by 4 is 4.25. 4.25. Now, let's just double check. Let's see if this makes sense. Going back to what we said earlier. We said that 5 lots of the number, so 5 times 4.25 minus 11, what do we get? That should be the same as 4.25 plus 6, shouldn't it? So let's check that this is right. 5 times 2.25 minus 11 equals a quarter, which is the same as 0.25. I've definitely gone wrong. Wait there. Yeah, I typed in the wrong thing into my calculator. Sorry, I get 41 over 4, which is 10.25. 4.25 plus 6 is 10.25. Do they equal the same thing? Yes, I know my x is correct. Perfect. So now we've done question 1 to 13 on the foundation, 1 to 15 on the foundation paper. Believe it or not, question 16 onwards, okay, 16 onwards, 16 to 26, I think. Question 16 is actually question 1 on the higher paper of this series. So January 21, 1 HR, this is question 1. This is question 2. Question 18 is actually question 3. Question 19 is actually question 4. Okay? So the rest of this video will be on the higher paper and I'll put the link on it. Look below. However, what you can see is there's a clear transition between the foundation paper and the higher paper. So those of you who are looking to transition from foundation to higher, really we should be concentrating on the last 10 questions. And the last 10 questions equate to 40 marks. Okay? Well done. Then question 20 is question 5. We have question 6, question 7, question 8, question 9, and question 10. And there actually were 40 marks. 40 marks, the last 10 questions. So what I suggest you do is watch the other video to find the rest of the paper. Thank you for watching. Please like and subscribe. Have a wonderful day.